Today we're talking division of polynomials. The goal is to long divide polynomials. So let's do a quick little review of long division, because maybe it's been a while, right? So in the first example, let's long divide 687 by 9. So do you remember what you do? You set up, I call it the division garage. Nobody else calls it that. I think that's my own invention. The division garage. Okay, 9 goes into 687. So you have the Pinto in the driveway and the nicer Mercedes or whatever car you like inside the garage. This is the garage door, right? Makes sense. Division garage. So put 687 inside the division garage, 9 on the outside in the driveway, and then do you remember what the process is? It's called an algorithm. The long division algorithm. An algorithm you hear about in computer science a lot, because it's a well-defined set of rules for that the computer has to carry out to accomplish some program or app that you create. Well, some function of the app, that is. So 9 goes into 687. Well, we start with 9 into 6, right? That digit in the 10 spot or the 100 spot there. But 9 doesn't go into 6, right? So we go one digit over, 9 into 68. How many times does 9 go into 68 without going over? 7 times. So we put that 7 right above the 8, don't we? And then we multiply 7 times 9, 63. We put that right below the 6 and the 8. And then what do we do with the 63? Subtract it, or add the opposite, right? Same thing. So if we do that, what's left? 5, and then what do? You bring down the 7. Is this bringing back great memories from elementary school? No? Oh, sorry. Bring down the 7, but then you start the process all over again, don't you? You ask yourself, what can I multiply 9 by to get close to 57 but not go over? In other words, how many times does 9 go into 57 without going over? 6 times. 6 times 9 is 54. Add the opposite, which means subtract. 57 minus 54 is 3. And that's your remainder, isn't it? Now, okay. You may remember a more sophisticated way to write this, but when you first learned long division, you probably wrote it as 76R3. Does that look familiar? 76 remainder 3. So let's review some terminology which is going to carry over to long division of polynomials. What is the quotient of this long division? The quotient is the 76, isn't it? The quotient is 76. The remainder? The remainder is the 3, right? R3. So the remainder is the 3. Does anybody remember how to check the long division? In this particular case, what would the check be? To check your answer. Yeah, 9 times 76 plus 3 had better equal what? Yeah, so you take 9 times 76, add 3, and you better get the thing you were dividing into. It's called the dividend. You better get the 687. And you will. You can check that on your own if you want. So it's going to check. But what's the check in general, if we remember some of the names of these things? 9 is called the divisor. Remember that? The divisor. It's coming back. I know it's all coming back to you, right? So the check on division, you take the divisor times the quotient, right? Divisor times the quotient. You add in the remainder, which I'm just going to call capital R. And that had better equal the dividend, which is the guy you're dividing into, right? Everybody remember that check on division? It comes in useful. It works when we long divide polynomials too. Okay. So, okay, that was great fun. I enjoyed that. What is it going to look like when we long divide polynomials? Well, okay, first of all, think about it this way. For any particular value of x, a polynomial is just a number, right? So it makes sense we can divide polynomials like we do with numbers, because for any particular value of x, a polynomial is a number. So it shouldn't come as a big surprise that the process is going to be very similar. So in this example, we're going to long divide x squared minus 6x plus 9 by the quantity x minus 3. And we're going to set up the division garage just like before. So what are we going to put in the driveway? The driveway, we put in the car we don't like as much, right? We don't care if it gets rained on or the sun destroys it after a few years. We'll put x minus 3 in the driveway, and inside the garage, we put the bigger, nicer car. X squared minus 6x plus 9, right? So here's the process. Yeah, there's an easier way to do this one. Some of you might have noticed, but I'm trying to demonstrate the process that'll work every time. So the process is this. Think of a number that you can multiply x by. Now, when I say x, everybody look up at the screen. I'm thinking of that x. Think of a number you can multiply this x by to get x squared. Or not a number, really, it's a variable. So what could you multiply x by to get x squared? X. So we're going to put that result right here. Now, different books will tell you to do it differently, but I like to put the x above its like term inside the garage. So this x above the minus 6x. I think it's a nice way to organize it. And then, well, wait, let's go back and refer to that first problem that we did. The analogous part of the problem we're at is when we put the 7 up top, okay? And then what did we do after we put the 7 up top? We multiplied it times the 9, right? And then we got the 63 right there. So we're going to do the same exact thing here. Now we're going to take the x times the x minus 3 times the entire divisor. So you have to think of it as being in parentheses. What is x times the entire divisor? X squared minus 3x. Does everybody see that? Yeah? Okay, so then what did we do? So we were at this point when we got it was actually positive 63, right? And then what did we do with the 68 and the 63? We added the opposite of 63, right? We're going to do the same thing here. In other words, we subtracted, you're right. So we're going to add the opposite of x squared minus 3x to what lies above it, the x squared minus 6x. So maybe we should go ahead and take the opposite, right? And then add. So we add, by design, the x squared and the negative x squared, those lead terms, they better go away. And they do. X squared plus a negative x squared makes 0. But what about the minus 6x plus 3x? Everybody catch that I changed both signs? I'm changing both signs and adding. That's the same as subtraction. So what do we get when we take the negative 6x or the minus 6x plus 3x? Minus 3x. And then, okay, wait. So that was when we're at the analogous step where we got the 5. 68 plus a negative 63 is 5. Then what did we do? We brought down the 7, right? We're going to do the same thing here, except we have to bring operations down along with the numbers. So we're going to bring down the plus 9. We're going to bring down the plus 9. Does that make sense? Then you start the process all over again, just like we started the process over again once we brought down this 7, right? So you start the process all over again, and you ask yourself, what can I multiply this x by? Yeah, you can barely see my cursor, so I'll circle it. What can I multiply this x by to get minus 3x? So minus 3, and you do include the operation, so minus 3 right there, above the 9 inside the garage, like terms. And then distribute the minus 3 to the x minus 3. What do you get? Right? So you're going to distribute this minus 3 to the x minus 3. What do you get? So it'd be minus 3x, right? So you're just distributing a negative 3 to x minus 3. So negative 3x plus 9. So what's going to happen this time when we change the signs and add? We get 0. So what's the remainder? There's nothing left to bring down. You know you're done. There's nothing left to bring down. The remainder is 0. So the quotient, Q for quotient, is x minus 3. And the remainder is 0. So what does the check on division tell you then? Since the remainder is 0, the check on division tells you what? Okay, what's the check? You take the divisor times the quotient and add in the remainder, and that had better equal the dividend. So that's telling you that x minus 3, you could look at that as the divisor, times the quotient, which is also x minus 3, plus 0, had better equal the dividend. Does it? Yeah, in fact, you guys have been going backwards lately, right? X squared minus 6x plus 9 factors to be x minus 3 times x minus 3, doesn't it? That's the same thing as saying x minus 3 times itself equals x squared minus 6x plus 9. It works. So when the remainder is 0, it gives you an additional way to factor a polynomial, which is going to be really important if you take college algebra. So when the remainder is 0, you get a factorization. The check gives you a factorization of the dividend. Again, that's going to be really important later on. Now, what was the easier way to do this problem, though? Couldn't you just have rewritten the original problem as x squared minus 6x plus 9 over x minus 3, and then did the usual simplifying, factor the numerator, then cancel out the like factors, leaving you with x minus 3? Yeah, that would work.